Okay, so we're going to start off with converting fractions to decimals. In these first two problems, we're going to use equivalent fractions, and then in the last two problems, we're going to use long division. So you can use equivalent fractions when you notice that the denominator is a factor of 10, 100, 1,000, 10,000, any number that's a factor of some power of 10. So you can do a couple things with number 1. You know 5 can go into 10. So we're just going to convert that to an equivalent fraction that's over 10. And you know that 5 times 2 is 10, so we have to multiply the numerator by the same number, and 8 times 2 is 16. And we get 16 tenths. 16 tenths. Well, that's more. Well, that's an improper fraction, so you could say 1 6/10, which in decimal form is 1 6/10. Okay, for this next one, we have 25, and 25 always makes me think of quarters. Quarters go into a dollar. A dollar is basically 100 cents. So we're going to convert to an equivalent fraction over 100. 25 times 4 is 100. So we'll multiply the numerator by 4 as well. And we get 6 times 4 is 24. 24 hundredths is 24 hundredths in decimal form. When you have fractions that have denominators that are not factors of a power of 10, like it doesn't go into 10 or 100 evenly, then you'll just want to use long division. And so you want to be careful about how you set that problem up. 2 over 9, 2/9 is the same as saying 2 divided by 9. And in long division, you would set that up with a 9 on the outside of your bracket and your 2 on the inside. And then you would start dividing. Well, you know 9 doesn't go into 2, so you have to add a decimal and a 0 because 9 goes into 20. So 9 doesn't go into 2, but 9 goes into 20 twice. 2 times 9 is 18. 20 minus 18 is 2. Add a 0, bring it down. 9 goes into 20, again, 2 times. So it looks like there's a pattern here. 9 times 2 is, again, 18. So we're just going to keep getting 2 as our remainder. So that means we have a repeating decimal of 0.2 repeating. Okay, here we have a negative fraction. Again, 11 does not go into 10 or 100 or 1,000 evenly, so we want to do long division. Since it's a negative fraction, we can make either the numerator or the denominator negative. Doesn't matter, just in the long run, our decimal form is also going to be negative. So this is the same as saying like -2 divided by 11. I'm going to remove and kind of forget about the negative sign for now. We'll just make sure that it's in our decimal for later. We'll finish filling this out once we're done dividing. So 11 doesn't go into 2. So I had a 0 and a decimal. But 11 goes into 20 once. And 20 minus 11 is 9. Add a 0, bring it down. 11 goes into 98 times because that's 88. 90 minus 88 is 2. Oh, we're getting that 2 again. And we're getting 11 goes into 20 one time. We'll get 11. So we're going to end up repeating. We're getting a pattern. So the digits that are repeating are the 1 and the 8. So those are the only 2 digits we need to write down with the repeating bar.